All right, the next example we have, example 4, is to find the derivative of this horribly nasty looking expression using a method called logarithmic differentiation. So all logarithmic differentiation is, we take some starting thing that we want to differentiate, but instead of beginning with the derivative, we first take the natural log of each side, then differentiate. Why would we do that? Well, the natural log has some really nice properties. In particular, it has the following 3 properties. So property 1 is, now every logarithm has these 3 properties, not just the natural log, but we're just going to use the natural log because all logarithms are proportional to one another, so there's really no need to have multiple logarithms. We can just work with natural log of x. Similarly, all exponential functions are proportional, so there's no need to work with all of them, just work with e to the x. So in this case, I'm just going to write everything in terms of natural logs. So the natural log of 2 things multiplied together, call them a and b, and this a and b can be anything. It could be functions, it could be many things. This is the natural log of the one plus the natural log of the other. The natural log of a divided by b is the natural log of a minus the natural log of b. And the third property that we're going to use a lot here is the natural log of a raised to some power, let's say k. This is k times the natural log of a. So it's these 3 properties of logarithms that give us a lot of flexibility when it comes to making algebraic simplifications. So with that being said, we're going to begin by taking this equation and taking the natural log of each side. So take the natural log of y equals, and now when we use these 3 laws or properties of logs up here, we can do them more, we can use more than one of them at a time. So for instance, if we notice here in the top, in the numerator, we've got 2 things multiplied together. So that means we can split this up into the log of this first term plus the log of this second term. Similarly, because this term is in the denominator, we can, after we take the sum of the log of this term plus the log of that term, we can subtract the log of this term. Not only that, but this term here has a power of 2. So when we have our log of this term, we can just write this as 2 log of that. Similarly, a square root is no different than a 1/2 power. So in one line, we can actually go all the way to 2 natural log of x plus 1 plus the natural log of 2x squared minus 3 minus 1/2 the natural log of x squared plus 1. Now we can differentiate both sides. All right. So the left-hand side is 1 over y dy dx equals, now we've got a bunch of logs here. So one thing we want to keep in mind, we know already that the derivative of the natural log of x we learned earlier in this section is 1 over x. But what if the inside of the logarithm is different than x? Maybe it's something more complicated than just a single x by itself. Well, then this would be regular old chain rule. 1 over the inside times the derivative of the inside. Or, if you want to think about it like this is how I usually think about it. Derivative of the inside divided by the inside. That's ultimately what the chain rule applied to the derivative of a natural log of some function turns into. So I usually don't think of it like this. I usually think of it like this. So in this case here, these derivatives are pretty quick. We're going to have 2 times derivative of the inside divided by the inside plus derivative of the inside divided by the inside minus 1/2 derivative of the inside divided by the inside. And of course, if you want to, you can clean this up and write, sometimes it looks nicer just to write things like that. Not necessary, though. Now, what we want to do in this stage here is, because this y is on the bottom side, we want to solve for dy dx. So we're ultimately going to multiply this by a y. So let's go ahead and do that. And in the final step here, what we want to do is we want to replace what y is, because we know what y is. Y is all the way up here. Oops. So if we make that replacement, we'll have x plus 1 quantity squared, 2x squared minus 3, all over the square root of x squared plus 1, times this whole expression, which we can just copy paste. And that is how you do logarithmic differentiation. First step is to log both sides and to simplify. So log each side, simplify. So the 2 comes out, the 1/2 comes out, you split it into 3 logs. Then you differentiate, that's step 3. Step 4 is to solve for dy dx, and step 5 is to replace y with what you know y is equal to. That's logarithmic differentiation.